Look up at the night sky. What do you see? A canvas of shimmering stars, fixed and eternal, untouched by time. That's the illusion, because the truth is, even the grandest cosmic wonders, those glittering star clusters that have guided sailors and inspired poets for millennia, are slowly, inevitably fading away. They collapse, dissolve, and vanish, just like everything else in this universe. And here's the beautiful paradox: their impermanence is what makes them so profound. Today, we're going on a journey, not just through space, but through time, philosophy, and the very nature of existence itself. We'll unravel the science of why star clusters collapse, how their deaths mirror our own fleeting lives, and what these celestial timekeepers can teach us about letting go, embracing change, and finding meaning in the temporary. Think about it. A single star cluster can contain thousands, even millions of stars, all bound together by gravity's invisible threads. They burn bright for billions of years, far longer than human civilization has even existed. And yet, eventually, they too succumb to the universe's relentless march toward chaos. Stars drift apart, black holes lurk in their cores, and tidal forces pull them into cosmic oblivion. But here's where it gets fascinating. This isn't just a story about astronomy, it's a metaphor for life. The same forces that dismantle star clusters also shape our lives: time, gravity, entropy, and the delicate balance between holding on and letting go. So why does this matter? Because understanding the impermanence of star clusters does something extraordinary. It reframes how we see ourselves. If even the heavens aren't eternal, what does that mean for us? It's humbling, yes, but also liberating. There's a strange comfort in knowing that nothing lasts, not even the stars. It means every moment, every connection, every spark of light in our lives is precious precisely because it won't be here forever. By the end of this journey, you'll see the night sky differently. Those stars, they're not just distant suns, they're silent teachers, showing us how to shine while we can, how to let go when we must, and how to find beauty in the fleeting. So take a deep breath, look up, and let's begin. Star clusters begin their lives as cosmic nurseries, where vast clouds of interstellar gas and dust slowly coalesce under the gentle pull of gravity. Picture a swirling nebula glowing faintly in the darkness, a place where chaos gradually gives way to order. Over millions of years, pockets of dense material collapse inward, igniting the nuclear furnaces of newborn stars. These stars don't form in isolation. They emerge together, bound by gravity into a celestial family. Some clusters, like the Pleiades, are loose and young, their stars still wrapped in wisps of their birth cloud. Others, like the ancient globular clusters orbiting the Milky Way, are dense spheres of stars that have endured for nearly as long as the universe itself. But no matter how tightly bound they seem, star clusters are never truly permanent. Their fate is shaped by forces both within and beyond their boundaries. Inside a cluster, stars move in a delicate dance, their gravitational interactions constantly shifting the balance. Close encounters fling some stars outward like cosmic slingshots, while others sink deeper toward the center. Over time, this slow redistribution of energy causes the cluster's core to contract, while its outer edges fray away. Meanwhile, external forces like the tidal pull of their host galaxy stretch and distort the cluster's shape, stealing stars one by one. What's fascinating is how predictable this process is. Astronomers can trace the life cycle of a star cluster, much like we track the growth and aging of a living thing. The youngest clusters glow with hot blue stars, their energy fierce but fleeting. Middle-aged clusters show a mix of survivors, the massive stars long gone, leaving behind steadier, cooler siblings. And the oldest, they're ghosts of their former selves, their stars scattered or huddled in dense, dark cores. The lesson is clear: even the grandest structures in the universe are subject to time's relentless flow. This cosmic impermanence forces us to reconsider our place in the universe. We tend to think of the stars as eternal, but they're just as transient as we are, only on a timescale so vast it defies human imagination. A star cluster's lifespan might span billions of years, but its story still has a beginning, a middle, and an end, and in that there's a strange comfort. The universe doesn't play favorites. Nothing escapes the pull of change, not even the glittering jewels of the night sky. So the next time you look up at a star cluster, remember, you're witnessing a moment in its grand, unfolding story, a story that mirrors our own in ways both humbling and profound. Star clusters don't fade with a dramatic explosion or a sudden burst of light. They dissolve like sugar in water, gradually and almost imperceptibly. Picture a crowded dance floor where every movement affects someone else. Stars in a cluster behave the same way, their gravitational interactions constantly reshaping the group's destiny. When two stars swing too close to each other, the energy of their encounter can fling one outward like a slingshot, sending it drifting into the void of interstellar space. This slow but steady loss of members weakens the cluster's gravitational glue, making it harder for the remaining stars to hold together. Over millions of years, these tiny ejections add up, thinning out the cluster until it's barely recognizable. Then there's the relentless pull of the galaxy itself. As star clusters orbit their host galaxy, they pass through regions of varying gravitational intensity. Imagine stretching a piece of taffy. The outer edges get pulled away first, while the center remains momentarily intact. That's exactly what tidal forces do to clusters. Stars on the fringes are peeled away by the galaxy's gravity, leaving the core slightly more vulnerable each time. Some clusters, like those near the Milky Way center, face even stronger tidal forces, hastening their demise. It's a cosmic tug of war where gravity always wins, but the most fascinating mechanism might be something called two-body relaxation. In a dense cluster, stars are constantly jostling, exchanging energy like players in a game of hot potato. Over time, this redistribution of energy leads to a curious phenomenon. The cluster's core contracts while its outer layers expand. Stars in the center crowd closer together, sometimes forming binary pairs or even triggering collisions, while those on the edges drift further away. This core collapse isn't the end, it's a transformation. The densely packed center might birth new interactions, like black holes merging or stars being flung out at incredible speeds. Yet even these dramatic events only delay the inevitable. What's striking is how these celestial processes mirror the delicate balances we see in nature and in our own lives. A forest thrives until a single wildfire resets the ecosystem. A sandcastle stands tall until the tide reclaims it. Star clusters remind us that stability is fleeting, an illusion maintained only until the next gravitational nudge or the next passing galaxy. The universe operates on a scale of time we can barely fathom, but the lessons are immediate. Everything, whether a cluster of stars or a moment in our lives, exists in a state of delicate equilibrium, always one shift away from change. And perhaps that's the beauty of it all. Nothing lasts, but in that impermanence there's room for new beginnings. Centuries ago, when astronomers like Charles Messier carefully charted the night sky, they saw star clusters as fixed landmarks, celestial lighthouses meant to guide navigation or aid in finding other objects. Messier's famous catalogue, compiled in the 1700s, listed these clusters as static wonders, their brilliance seemingly eternal. But what he couldn't have known was that these glittering assemblies were already in motion, their fates sealed by forces beyond human perception. Fast forward to today, and modern telescopes like Hubble have peeled back the illusion of permanence, revealing star clusters as dynamic, evolving systems with lifespans as dramatic as they are inevitable. Take the Hyades, that familiar V-shaped cluster in Taurus. Visible to the naked eye, it's long been a fixture of myth and astronomy alike. But Hubble's precise measurements show its stars are drifting apart, their gravitational bonds weakening as they respond to the Milky Way's tidal forces. Within 100 million years, a blink in cosmic terms, the Hyades will scatter entirely, its stars absorbed into the galaxy's general population. Contrast that with globular clusters like M15, a dense swarm of ancient stars in Pegasus. Here, the core is so packed that stars collide or merge, while the outer regions steadily erode. These two clusters represent opposite ends of the same story, one dissolving gently, the other collapsing inward, yet both marching toward the same inevitable dissolution. What's remarkable is how these observations shatter our instinctive belief in cosmic constancy. The night sky feels timeless, but the reality is a universe in flux. Even the oldest globular clusters, some nearly as old as the universe itself, bear scars of their slow unraveling. Their tightly wound cores, where stars crowd like commuters in a subway car, are telltale signs of core collapse, a phase where gravitational interactions have siphoned energy outward, leaving the center to contract into a dense knot. It's a process that unfolds over eons, yet it's as inexorable as erosion shaping a canyon. These celestial time capsules also hint at a deeper truth. Transformation isn't destruction, but a kind of reconfiguration. When a cluster like Palomar 5 stretches into a stellar stream, its stars don't vanish, they become part of the galaxy's tapestry, their material recycled into new generations of stars. In that sense, the clusters Messier catalogued aren't gone, they've simply traded one form for another. The past whispers to us through these changes, reminding us that the universe thrives on reinvention. Whether it's a star cluster fading or a civilization rising and falling, the pattern repeats. Nothing stays, but nothing is truly lost. So the next time you gaze at a star cluster, remember, you're not just seeing a snapshot. You're witnessing a frame in a cosmic film that's been playing for billions of years. The stars themselves may not care about their impermanence, but for us, there's wisdom in their transience. They teach us that change isn't just inevitable, it's the very engine of the universe's story, and in that there's a strange, shimmering kind of comfort. Dark matter is the universe's silent puppeteer, an invisible force shaping the cosmos in ways we're only beginning to understand. While its gravitational grip molds galaxies into grand spirals and vast ellipticals, its influence on star clusters is more subtle but no less profound. Picture a cluster sailing through the Milky Way, its stars seemingly bound only to each other, but in reality, it's also moving through an ocean of dark matter, an unseen current that tugs at its structure over time. Some clusters, like those orbiting close to the galactic center, plow through dense dark matter halos, their paths subtly altered by gravitational nudges we can't see but can measure. These interactions may seem minor, but over billions of years, they add up, pulling stars away like stealthy thieves in the night. Then there's Palomar 5, a ghostly cluster stretched into a shimmering stellar stream. Once a compact family of stars, it's now a ribbon of light arcing across the sky, its stars scattered by encounters with dark matter clumps. These clumps don't glow or emit radiation. They're detectable only by their gravitational fingerprints. Palomar 5's fate is a cosmic cautionary tale. Even the most stable-looking systems are vulnerable to forces they never see coming. It's a reminder that the universe operates in shadows as much as in light, and what we can't perceive often has the greatest impact. What's fascinating is how dark matter doesn't just hasten a cluster's dissolution, it reshapes the very way it dies. In clusters like Palomar 5, dark matter doesn't tear stars apart violently. Instead, it gently unravels them like a thread pulled from a tapestry. The process is slow, almost elegant, as stars are peeled away one by one, their trajectories bent by encounters with invisible mass. This isn't destruction in the traditional sense. It's more like a cosmic reweaving, where the cluster's stars become part of the galaxy's broader fabric. This hidden interplay between dark matter and star clusters mirrors something deeply human, the way unseen forces shape our lives. We might attribute events to chance or visible causes, but often it's the quiet, background influences, the relationships we don't notice, the small choices we forget that steer our paths in ways we only recognize in hindsight. Dark matter teaches us that impermanence isn't always about dramatic collisions or fiery explosions. Sometimes it's the cumulative effect of invisible nudges, the slow and steady work of forces we may never fully see but can't escape. So the next time you hear about dark matter, don't just think of it as some far-off cosmic mystery. Think of it as the quiet architect of change, the unseen hand that reminds us even the most enduring structures are subject to forces beyond their control. Whether in the life of a star cluster or the arc of a human life, the lesson is the same. What we don't see still shapes us, and sometimes that's where the most profound transformations begin. Stars in clusters share a cosmic cradle, born from the same swirling cloud of gas and dust, yet their deaths couldn't be more different. Imagine a family where siblings live wildly divergent lives. Some blaze brightly and leave abruptly, while others fade quietly into old age. That's the story of stellar mortality. The most massive stars, those giants 10 times heavier than our sun, live fast and die young. Their final act is a supernova, a cataclysmic explosion so powerful it can outshine an entire galaxy for weeks. When this happens inside a cluster, the shockwave ripples through the surrounding stars, ejecting gas, dust, and even neighboring stars like cosmic shrapnel. These violent departures destabilize the cluster's delicate gravitational balance, leaving voids where stability once reigned. But not all stars go out with a bang. Smaller stars like our sun take a gentler path. After billions of years, they shed their outer layers, leaving behind a dense, Earth-sized ember called a white dwarf. These remnants glow faintly with leftover heat, cooling over eons like forgotten coals in a fireplace. While they don't disrupt the cluster dramatically, their silent exit still matters. Every star that becomes a white dwarf subtracts mass from the cluster, weakening its gravitational pull. Over time, these quiet losses add up, making it easier for surviving stars to drift away. It's a slow bleed, but just as consequential as the supernova's sudden slash. What's fascinating is how these deaths intertwine. A single supernova can fling dozens of stars into exile, but the cumulative effect of white dwarfs might ultimately doom the cluster just as surely. It's a reminder that mortality isn't just about how things end, it's about how those endings reshape what's left behind. The cluster isn't just a collection of stars, it's a dynamic system where every loss reverberates through the whole. This cosmic life cycle mirrors our own human experience in unexpected ways. Think of a community. Each member's departure, whether sudden or gradual, leaves an imprint. Some losses are seismic, altering the fabric of the group overnight. Others are subtle, felt only in the slow erosion of shared history, but collectively they define the group's evolution. Stars, like people, don't exist in isolation. Their lives and deaths are threads in a larger tapestry, each one pulling at the weave in its own way. There's a poignant lesson here about resilience and change. Clusters don't collapse the moment the first star dies. They adapt, recalibrate, and persist until they can't. That tension between endurance and impermanence is universal. Whether it's a star cluster or a family, a friendship or a civilization, the same truth holds: endings are inevitable, but so is the capacity to endure them. The stars, in their silent way, teach us that mortality isn't just an end. It's part of the rhythm that keeps the universe and us moving forward. Deep in the hearts of some star clusters, invisible monsters lurk: black holes, the remnants of massive stars that collapsed under their own weight. These gravitational beasts don't announce their presence with flashing lights or roaring jets. Instead, they work in silence, reshaping their surroundings in ways both subtle and devastating. Picture a crowded room where one person starts pulling others toward them with an invisible force. That's what happens when a black hole settles into a cluster's core. Stars that drift too close are either swallowed whole or flung outward at incredible speeds, their trajectories altered forever by an encounter they never saw coming. The process begins when the most massive stars in a cluster exhaust their fuel and collapse, leaving behind black holes. Over time, these dark remnants sink toward the center, a phenomenon called dynamical friction. Like marbles rolling through honey, they lose energy as they move, gradually settling into the cluster's heart. Once there, they become gravitational puppeteers. Some stars are ripped apart by tidal forces, their material spiraling into the black hole's maw in a brilliant but doomed display. Others are ejected entirely, slingshotted away by the black hole's gravity in a cosmic game of pinball. Each interaction saps the cluster's energy, hastening its collapse from the inside out. What's astonishing is how efficient this destruction is. A single black hole can eject dozens of stars over millions of years, thinning the cluster's population like a sculptor chiseling away stone. In dense globular clusters like M15, astronomers have detected the telltale signs of these invisible architects, stars orbiting empty patches of space where black holes must reside. The damage isn't always dramatic, but it's relentless. Like termites gnawing at the foundation of a house, black holes undermine the cluster's stability, one stolen star at a time. This unseen influence mirrors a profound truth about life. The most transformative forces are often the ones we never see. A single whispered rumor can unravel a community. A quiet doubt can erode years of confidence. Black holes teach us that destruction doesn't always come from the outside. Sometimes it grows within, hidden but inevitable. Yet there's a strange beauty in this process. The same black holes that dismantle clusters also seed the galaxy with rogue stars, sending them spiraling into the void where they might one day ignite new systems. Even in collapse, there's creation, a reminder that endings are never absolute, just rearrangements on a cosmic scale. So the next time you hear about a star cluster's demise, remember the silent architects working behind the scenes. Their story isn't just about destruction, it's about the invisible forces that shape the universe and us in ways we're only beginning to understand. Imagine compressing the entire lifespan of a star cluster, billions of years of cosmic dance, into a single afternoon. That's the magic of computer simulations, where astronomers wield supercomputers like time machines, fast-forwarding through eons to unravel the fate of these celestial families. These aren't just video game-like recreations, they're precision-crafted models governed by the same laws of physics that shape the real universe. Every star, every gravitational tug, every chance encounter is calculated with meticulous detail, revealing patterns invisible to telescopes. What emerges is a startling truth. A cluster's destiny is written in its infancy. The initial density of stars, the way they're packed together like seeds in a pomegranate, determines whether it will endure for billions of years or dissolve into the galactic background within a cosmic blink. Take the case of Omega Centauri, one of the Milky Way's largest globular clusters. Simulations show that its remarkable longevity stems from its birth conditions, an unusually dense core that acts like a gravitational anchor, resisting the tidal forces that shred looser clusters. But tweak just one variable, like the initial distribution of stellar masses, and the outcome shifts dramatically. Fewer massive stars mean fewer supernova, which means less disruption to the cluster's delicate balance. It's a cosmic domino effect where tiny differences snowball into divergent futures. These virtual experiments reveal something profound. The universe is exquisitely sensitive to initial conditions. A slight variation in a cluster's starting point can mean the difference between a tight-knit community surviving for billions of years and a scattered diaspora of stars lost to the void. What's even more fascinating is how these simulations mirror the unpredictable nature of our own lives. Just as a single close encounter between stars can alter a cluster's trajectory, small choices, a missed opportunity, a chance meeting, ripple through time, shaping destinies in ways we can't foresee. The algorithms astronomers use to model stellar motions aren't so different from the variables that govern human connections: proximity, momentum, the push and pull of unseen forces. Both systems, celestial and personal, thrive on contingency, where minor events cascade into outsized consequences. Yet simulations also offer hope. They show that even in collapse, there's order. A disintegrating cluster doesn't vanish chaotically. It follows patterns, leaving behind stellar streams or seeding new star formation with its expelled gas. This isn't randomness, it's entropy with a blueprint. And that's perhaps the most humbling lesson of all. Whether we're staring at a supercomputer's visualization or the night sky, we're witnessing the same story. A universe where impermanence isn't chaos, but a kind of poetry written in the language of gravity and time. The stars, real or simulated, remind us that every ending is also a rearrangement, a scattering of seeds for whatever comes next. A single star, drifting just a fraction closer than usual, can rewrite the destiny of an entire cluster. This is the butterfly effect in its purest cosmic form, where minute changes spiral into consequences as vast as the universe itself. Picture two stars passing within a light year of each other, their gravitational whispers too faint to measure. Yet that brief encounter nudges one star onto a new path, altering its future interactions. Over millennia, that star might collide with another, eject a third, or spiral toward the cluster's center to feed a lurking black hole. What began as an imperceptible shift cascades into a transformation no telescope could have predicted. The same principle applies to forces beyond the cluster's borders. A dwarf galaxy drifting too close stretches the cluster's outer stars like taffy, stealing them away one by one. A supernova shockwave from a neighboring star compresses nearby gas, triggering unexpected new star birth or scattering existing stars like billiard balls. These events aren't random, they're the universe's way of reminding us that everything is connected, and no system, no matter how stable, is immune to the ripple effects of change. What's astonishing is how these microscopic perturbations mirror the turning points in our own lives. A missed train leads to a chance meeting that alters a career. A casual remark inspires a lifelong passion. Like stars in a cluster, we're buffeted by forces seen and unseen. Our trajectories shaped by moments so small we barely notice them until years later, when we trace the path back and realize how much hinged on that one instant. The cosmos doesn't play favorites. Whether you're a star or a human, existence is a tapestry of near-infinite variables, where the slightest thread can unravel or reweave the entire pattern. Yet there's a paradox here. While chaos theory suggests unpredictability, simulations show clusters often follow broad patterns of dissolution. It's like knowing a sandcastle will eventually crumble, but never being able to guess which grain of sand will start the collapse. This tension between order and chaos is what makes star clusters such profound teachers. They don't just show us how things fall apart, they reveal how beauty emerges from that disintegration. A cluster's death throws birth stellar streams, rogue stars flung into the void, and even new star-forming regions. Destruction becomes creation, just as a forest fire clears the way for new growth. So the next time you feel overwhelmed by life's unpredictability, look to the stars. Their chaos isn't meaningless, it's the engine of reinvention. A cluster's collapse isn't an ending, it's a redistribution, a reminder that even the most fleeting moments contribute to a grander design. The universe thrives on these tiny, invisible shifts, and so do we. Every choice, every chance encounter, every butterfly's wingbeat matters far more than we can ever know. Globular clusters are the ancient titans of the cosmos, dense, spherical cities of stars that have endured for nearly the age of the universe itself. Picture a swarm of fireflies trapped in amber, their lights frozen in a tight-knit dance that survived galactic collisions, supernova shocks, and the relentless pull of dark matter. These clusters, like Omega Centauri or M13, are fortresses of gravity, their stars packed so tightly near the core that a single light year could contain thousands of suns. That density is their armor. It allows them to resist the tidal forces of their host galaxy for billions of years, weathering the storms that would shred looser structures. But even titans fall. Over eons, their cores contract further, stars crowding inward until gravitational interactions fling them outward or feed them to lurking black holes. The collapse isn't explosive, it's a slow, inevitable crumpling, like a sandcastle eroding grain by grain under an invisible tide. Now contrast that with open clusters, the cosmic wildflowers of the galaxy. Think of the Pleiades, its bright young stars sparkling like dewdrops on a spider's web, beautiful but fleeting. Born from the same gas clouds as globulars, open clusters lack their dense, gravitational glue. Their stars are loosely bound, often just a few hundred siblings drifting together through the galactic disk. Without the tight-knit structure of globulars, they're vulnerable to every passing whim of the Milky Way. A nearby spiral arm's gravitational tug, a brush with a giant molecular cloud, even the gentle push of starlight radiation can pry them apart. Within a few 100 million years, a mere heartbeat in cosmic time, their stars scatter, joining the galaxy's background, glitter like drops of ink dissolving in water. Yet here's the cosmic irony. Both types of clusters, despite their stark differences, meet the same fate. A globular cluster might take 12 billion years to collapse, while an open cluster disperses in 500 million, but the end point is identical: dissolution. It's a reminder that structure doesn't defy impermanence, it merely delays it. The universe doesn't care if a cluster is tight or loose, ancient or newborn. Gravity and time are the great equalizers, reducing all things to the same quiet end. This duality offers a profound lesson about resilience and fragility. Globular clusters teach us that density and cohesion can create astonishing longevity, but even the mightiest structures harbor the seeds of their own demise. Their core collapse isn't caused by external forces, but by the very interactions that once held them together. Open clusters, on the other hand, show how beauty often lies in transience. Their brief, brilliant lives remind us that not everything needs to last to matter. A star cluster's value isn't measured in its endurance, but in the light it casts while it exists, whether for eons or moments. So when you look up at the Pleiades or spot Omega Centauri through a telescope, you're seeing two faces of the same cosmic truth. One is a monument to endurance, the other a testament to fleeting grace. Different paths, same destination, and in that there's a strange comfort. Whether we're built like fortresses or woven like spider silk, the universe welcomes all stories, as long as they're willing to shine while they can. The Milky Way isn't just a glittering spiral of stars. It's a cosmic predator, quietly devouring its smaller neighbors in a slow-motion feast that spans billions of years. Picture a spider at the center of an invisible web, feeling the faint tremors of passing prey. When a star cluster or dwarf galaxy ventures too close, the Milky Way's immense gravity stretches and shreds it, pulling stars away like celestial taffy until all that remains are scattered streams of light, ghostly remnants of what once was. One of the most striking examples is the Sagittarius dwarf galaxy, a tiny satellite galaxy caught in our galaxy's gravitational grip. Over time, the Milky Way has stripped away its stars, leaving behind a smeared trail of stellar debris that arcs across the sky like a cosmic scar. This isn't destruction for its own sake, it's how galaxies grow, absorbing smaller systems to fuel their own expansion. What's fascinating is the elegance of this process. The Milky Way doesn't consume clusters all at once. It dismantles them piece by piece, savoring the meal over eons. Tidal forces tug stars away from the cluster's outskirts first, leaving the core intact for a while longer. These stolen stars don't vanish, they become part of the Milky Way's halo, a vast, diffuse cloud of ancient stars that surrounds the galactic disk. In a way, the cluster's demise gives birth to something new, its stars repurposed into the galaxy's larger tapestry. It's a reminder that growth often comes at the expense of others, a universal truth as old as gravity itself. But there's a deeper irony here. The very clusters being torn apart today might owe their existence to similar acts of cosmic cannibalism in the distant past. Some astronomers believe globular clusters, those dense, ancient spheres of stars, could be the stripped-down cores of dwarf galaxies the Milky Way consumed long ago. Their resilience allowed them to survive the destruction of their host galaxies, becoming celestial refugees adopted into a new home. This cyclical dance of creation and consumption is woven into the fabric of the universe, where endings are just beginnings in disguise. This galactic predation mirrors patterns we see everywhere, from ecosystems to human history. Larger entities absorb smaller ones, not out of malice but simply because the rules of the system demand it. Forests expand by overshadowing saplings. Empires grow by assimilating cultures. Even in our own lives, we often outgrow old habits, relationships, or identities, shedding pieces of ourselves to make room for what's next. The Milky Way's cannibalism isn't cruel, it's inevitable, a natural consequence of gravity's unrelenting pull. Yet there's a strange beauty in this destruction. The stolen stars from clusters like those in the Sagittarius dwarf don't just disappear, they become part of the Milky Way story, their light mingling with generations of stars yet to come. In the grandest sense, nothing is ever truly lost, only transformed. So the next time you gaze at the night sky, remember, some of those twinkling lights might be survivors of cosmic battles fought long ago, their journeys a testament to the universe's endless cycle of loss and reinvention. Stretching across the night sky like faint brushstrokes on a cosmic canvas, stellar streams are the lingering echoes of star clusters that once were. These wispy trails of stars, often spanning thousands of light years, tell silent stories of gravitational disruption, a celestial autopsy revealing how clusters meet their end. Take GD1, a stellar stream first discovered winding through the constellation Hercules. What makes it extraordinary isn't just its length, over 90 light years, but its purity. Unlike other streams tangled with interstellar gas or distorted by recent encounters, GD1 stars move in near-perfect synchrony, like dancers frozen mid-step. This pristine alignment suggests its parent cluster dissolved billions of years ago, its stars gradually shearing apart under the Milky Way's relentless tides without subsequent disturbances. The process behind these ghostly ribbons is both violent and delicate. When a cluster passes too close to our galaxy's bulge or plows through a dense dark matter cloud, gravitational forces act like cosmic scissors, snipping stars from the cluster's outskirts first. These stolen stars don't scatter randomly, they follow the cluster's original orbit, forming elongated tails that stretch ahead and behind the dissolving core. Over time, the stream grows longer and thinner, its stars spacing out like beads on an invisible string. Some streams, like the one trailing the Phoenix cluster, even show gaps, empty stretches where dark matter subhalos punched through like bullets, leaving stellar voids in their wake. What's haunting about these streams isn't just their origin, but their imperceptibility. Unlike glittering star clusters, streams are achingly faint, often invisible to all but the most sensitive telescopes. The Palomar 5 stream, for instance, was discovered not by its light but by the synchronized motion of its stars, a celestial chorus singing in gravitational harmony. Modern sky surveys like Gaia have unveiled dozens of these phantoms, each a fossilized imprint of a cluster's final moments. They're the universe's way of preserving memory, proving that even in destruction, patterns persist. This cosmic archaeology offers more than just stellar history. It's a window into the Milky Way's hidden architecture. By mapping streams like GD1, astronomers reverse engineer the galaxy's gravitational field, pinpointing unseen dark matter clumps that warp the stream's path. It's akin to tracking ripples on a pond's surface to deduce the shape of submerged rocks. The kinks and bends in these stellar ribbons reveal the distribution of mass we can't otherwise see, turning destruction into discovery. There's poetry in how these streams mirror human legacies. Long after a star cluster dies, its influence lingers, reshaping our understanding of the galaxy, guiding new generations of stars, even marking the presence of the invisible. Nothing truly vanishes, it merely transforms. The next time you gaze at the night sky, remember, between the bright stars and familiar constellations, there are ghostly rivers of light flowing silently through the dark, each one a testament to the universe's quiet insistence that every ending leaves its mark. Star clusters measure their lives in billions of years spans so vast they defy human comprehension. Entire civilizations on Earth have risen and fallen in the time it takes for a single star in a distant cluster to complete one lazy orbit around its companions. The pyramids were built, empires crumbled, and technologies transformed the planet, all while those distant suns drifted imperceptibly through their stately cosmic dance. Against such scales, human existence registers as little more than a flicker, a fleeting spark in the endless dark. And yet, here we are, tiny beings on a pale blue dot, training telescopes and algorithms to decode the life cycles of structures that will outlive us by orders of magnitude we can scarcely fathom. This paradox, our ephemeral nature set against our hunger to understand the eternal, is one of humanity's most profound contradictions. We know our time is limited, yet we spend it studying the nearly limitless. Ancient astronomers carved star patterns into cave walls. Modern scientists map stellar streams with space telescopes. The tools have changed, but the impulse remains the same: to find meaning in the face of our own impermanence. There's something almost heroic in this pursuit, like ants meticulously reconstructing a sandcastle each time the tide erases it. We persist in documenting a universe that will forget us long before we've grasped even a fraction of its mysteries. Consider the Hercules globular cluster, a dense sphere of stars over 25,000 light-years away. Its light reaching us today began its journey when humans were first domesticating wolves and inventing agriculture. By the time that cluster finally dissolves billions of years from now, our species may well be gone, our monuments dust, our languages silenced. And yet, in this fleeting moment, we've captured its image, measured its motion, and unraveled its history. That act, that defiant act of witnessing, is our way of etching "we were here" into the cosmos. It's not immortality, but it's the closest thing we have. The assurance that for a blink in cosmic time we saw, we wondered, and we tried to understand. Perhaps that's why star clusters captivate us so deeply. They're not just celestial objects, they're mirrors. Their slow unraveling reflects our own fragility. Their resilience against impossible odds echoes our stubborn hope. When we study how clusters collapse, we're really probing the boundaries of our own existence, testing what it means to persist, to matter, even when the universe seems indifferent. The stars don't care about their impermanence, but we do. And in that caring, in that relentless curiosity, we find a kind of solace. The cosmos may be eternal, but we're the ones who get to marvel at it. So the next time you feel dwarfed by the scale of the universe, remember, the very act of feeling small is a triumph. Those ancient clusters may outlast us, but they'll never know the bittersweet beauty of a sunset, the ache of a goodbye, or the quiet joy of connecting dots in the night sky. We're fleeting, yes, but we're also the universe's way of understanding itself, and that's a role no star, no cluster, no galaxy could ever play. 2,500 years ago, the Buddha walked the dusty roads of India teaching a simple but radical truth, that all things are impermanent. He called this principle anicca, the idea that clinging to what must inevitably change is the root of suffering. Today, light years away from those ancient teachings, star clusters whisper the same lesson in a language of gravity and light. Their slow unraveling isn't just astrophysics, it's philosophy written across the cosmos. When we watch a cluster like M15 dissolve, we're witnessing the universe itself demonstrating what sages have long insisted. Nothing lasts, and in that impermanence lies both sorrow and liberation. Consider the Jewel Box Cluster, a dazzling array of young stars in the southern sky. To the naked eye, it sparkles like a handful of diamonds tossed onto black velvet, eternal, unchanging. But telescopes reveal the truth. These stars are drifting apart, their gravitational bonds weakening with each passing millennium. Within a few million years, they'll scatter into the galactic void, their brief kinship forgotten. This isn't tragedy, it's the natural order. The cluster's beauty doesn't diminish because it's temporary. If anything, its transience makes it more precious, like a sand mandala painstakingly crafted only to be swept away. The stars don't mourn their eventual dispersal, they simply burn brighter while they can. This cosmic impermanence mirrors a paradox at the heart of human experience. We build cities, forge relationships, and create art, all while knowing, on some level, that none of it will endure. The ancient Stoics called this memento mori, the practice of remembering mortality to sharpen appreciation for life. Star clusters offer a celestial version of that wisdom. Their collapse isn't a warning but an invitation to love deeply despite loss, to create boldly knowing it won't last, to find joy in the fleeting. A globular cluster's billion-year lifespan might seem eternal to us, but in the universe's eyes, it's as brief as a mayfly's dance in the sunlight. Scale is irrelevant. The lesson is the same. There's a quiet rebellion in this perspective. Modern life often pushes us to chase permanence, eternal youth, unshakable security, legacies that outlast time. But the stars remind us that fragility isn't failure. When the Hyades cluster finally disperses, its stars won't vanish. they'll become part of new stories, fueling future generations of suns and planets. In the same way, our moments of connection, creativity, and courage ripple outward long after we're gone. The Japanese concept of mono no aware, the poignant beauty of transient things, captures this perfectly. A cherry blossom is lovelier because it falls, a sunset because it fades. Star clusters, those celestial cherry blossoms, teach us that radiance and impermanence aren't opposites. They're inseparable, so the next time you feel the ache of time passing, a child growing up too fast, a favorite place changing beyond recognition, look to the night sky. Those ancient starlight symphonies are proof that endings aren't cancellations. They're transformations. The universe doesn't do forever, but in its infinite rearrangements, it offers something just as profound, the chance to shine, however briefly, in a darkness that will eventually claim us all. And perhaps in that shared impermanence, we find our deepest connection to the cosmos. Van Gogh's Starry Night swirls with turbulent energy, the heavens alive with motion, not as static pinpricks of light, but as a living, breathing entity. That famous cypress tree reaches toward the sky as if trying to grasp something eternal, while the stars themselves seem to pulse with impermanence, their luminous trails suggesting both brilliance and evaporation. It's no accident that one of history's most celebrated paintings captures not the stillness of the cosmos, but its relentless flux. Artists have long been drawn to star clusters not as frozen monuments, but as metaphors for the very transience they feared and revered. Tennyson's line, "The brightest stars burn fastest," isn't just astronomy, it's elegy, a recognition that the things which move us most are often the most fleeting. Literature, too, has woven stellar decay into its tapestry. In Pale Blue Dot, Carl Sagan reflects on how our planet is a mote of dust suspended in a sunbeam, a temporary haven in an ever-shifting universe. Mary Oliver's poem Stars describes them as fast and forever, a paradox that mirrors our own longing for permanence in a world of change. Even science fiction leans into this theme. Arthur C. Clarke's The Songs of Distant Earth imagines a civilization watching its sun go supernova, turning cosmic collapse into a backdrop for human resilience. These creators understood something fundamental. Star clusters don't just inspire awe, they mirror the creative process itself. Art, like starlight, is born from loss. A sculptor chips away marble to reveal form. A writer wrestles silence into story. And stars, they scatter their atoms across the void so new worlds might one day rise from their ashes. Music joins this chorus. Gustav Holst's The Planets gives us Neptune, the mystic, its eerie, unresolved harmonies evoking the slow dissolution of celestial bodies. David Bowie's Space Oddity turns an astronaut's isolation into a metaphor for humanity's fragile place in the cosmos. These works don't shy from impermanence, they amplify it, finding beauty in the unraveling. It's as if artists instinctively grasp what scientists quantify, that creation and destruction are two sides of the same coin. A dying cluster's light is both farewell and beacon, its glow a reminder that endings can illuminate as fiercely as beginnings. Perhaps this is why star clusters haunt our collective imagination. They're not just subjects for textbooks, they're mirrors. When a poet compares a lover's eyes to the Pleiades, or a filmmaker frames a hero's death against the backdrop of a nebula, they're tapping into a truth deeper than astronomy. The stars teach us that to create is to accept loss, to burn bright is to risk burning out. Every painting, every poem, every melody is a defiance of entropy, a refusal to let beauty fade without witness. The universe may not care that clusters collapse, but we do. And in that caring, we find not just art but meaning. For millennia, humans have looked to the stars as symbols of constancy, unchanging guides in an uncertain world. The ancient Egyptians aligned their pyramids with Orion's belt, believing the gods had fixed those stars in place forever. Polynesian navigators memorized the positions of celestial waypoints, trusting them to remain steady across generations of ocean voyages. Even today, we speak of eternal stars in poetry and promises, as if the heavens were a frozen tapestry rather than a living, shifting cosmos. But science paints a different picture. Those same constellations, Orion, Ursa Major, the Southern Cross, are temporary arrangements, their stars drifting apart at speeds that would horrify our ancestors. The Big Dipper, for instance, will unrecognizably stretch and warp within 100,000 years, its familiar ladle shape dissolving like ink in water. This tension between myth and reality reveals something profound about the human psyche. We crave permanence in a universe built on change. Consider the Greek myth of Callisto, transformed into the constellation Ursa Major by Zeus to protect her from Hera's wrath. The story assumes those stars were fixed for eternity, a celestial monument to divine intervention. Yet modern astronomy shows Ursa Major's stars are not only moving independently, but originated in different parts of the galaxy. The same applies to the Seven Sisters of the Pleiades, revered from Aboriginal Australian Dreamtime stories to Japanese folklore. Cultures across time and distance saw these tight star clusters as eternal sisters, unaware that gravitational forces are slowly pulling them apart. There's a poignant irony here. The stories we crafted to explain the stars' permanence will likely outlast the actual celestial configurations that inspired them. This cultural resistance to cosmic impermanence isn't just sentimental, it's practical. Early civilizations relied on stable star patterns for agriculture, navigation, and timekeeping. The Maya used Venus's predictable cycles to construct their calendar, while the Dogon people of Mali tracked Sirius's movements with astonishing precision. Recognizing that these celestial markers were temporary would have undermined their worldview, like discovering the hands of a clock were slowly melting. But the universe doesn't accommodate our need for stability. Even Polaris, our current North Star, will relinquish its position to Vega in 12,000 years, a fact that would have bewildered medieval navigators who trusted it as an unwavering guide. What's fascinating is how this disconnect manifests today. We know intellectually that stars evolve and die, yet emotionally, we still describe them through the lens of myth. NASA Hubble images of pillars of creation or stellar nurseries borrow the language of permanence and birth, even though those structures are transient and destructive. Social media lights up with panic whenever astronomers predict Betelgeuse might go supernova, as if a star's death were a cosmic betrayal rather than a natural event. This cognitive dissonance, knowing the stars change while feeling they shouldn't, mirrors our broader struggle to accept impermanence in our own lives. We build identities, relationships, and societies on foundations we imagine as solid, only to discover they're as fluid as the Milky Way's spiral arms. Yet there's wisdom in the myths too. By personifying stars as gods, heroes, or animals, ancient cultures acknowledged something science sometimes overlooks. The cosmos isn't just a clockwork mechanism, it's a story. The Maori tale of Ranginui, the Sky Father, and Papatuanuku, the Earth Mother, forcibly separated by their children to create the world, captures the dynamism of celestial bodies better than any textbook diagram. These narratives, though wrong by scientific standards, resonate because they embrace what raw data cannot: the emotional weight of living in a universe where even the stars are temporary. Perhaps that's the ultimate lesson. The heavens refuse to stay still, not to spite us, but to remind us that the only true constant is change itself, and that's where the real magic lies. We look up at the night sky and see familiar constellations: Orion's belt, the Big Dipper, the Southern Cross, as if they've been etched into the heavens with permanent ink. But this is an illusion, a trick of scale. The stars are moving at staggering speeds, some racing toward us at hundreds of thousands of kilometers per hour, others drifting apart like ships in an endless dark sea. If we could compress cosmic time into human scale, watching millennia pass in minutes, the sky would become a swirling ballet. Constellations would stretch and warp, their shapes melting like wax figures near a flame. The North Star wouldn't guide anyone, it would wander. The celestial landmarks we consider eternal are just momentary alignments, fleeting patterns in a universe that refuses to sit still. This cosmic restlessness mirrors a fundamental quirk of human psychology. We're wired to perceive stability even when it isn't there. Our brains crave patterns and constancy, smoothing over life's fluctuations to create the illusion of permanence. We convince ourselves our relationships, careers, and even identities are fixed until a sudden loss, a global event, or simply the passage of years forces us to confront the truth. Like ancient astronomers mapping immutable constellations, we build mental models of our lives that ignore the underlying chaos. The universe doesn't lie, we just aren't looking on the right timescale. Modern astronomy offers a corrective to this delusion. Time-lapse simulations of our galaxy reveal stars tracing graceful arcs over millions of years, like fireflies caught in a slow-motion whirlwind. The red giant Betelgeuse isn't just a point in Orion's shoulder, it's a traveler moving fast enough that in just a few thousand years, it will noticeably shift position. Even the Milky Way itself is rotating, its spiral arms turning like a colossal pinwheel. These animations don't just educate, they unsettle. They force us to reconcile our static mental maps with a dynamic reality, much like realizing a childhood home has been remodeled beyond recognition, or that a loved one's face has aged in old photographs. This tension between perception and reality isn't just philosophical, it's practical. Early seafarers trusted Polaris to guide them precisely because it appeared unchanging. Today's astronomers, ironically, must account for stellar motion to align telescopes accurately. The same applies to our personal lives. We base decisions on assumptions of stability, that jobs will last, health will hold, relationships will endure, only to be blindsided when change arrives. The stars teach us that adaptability isn't just useful, it's essential. A sailor who ignores Polaris's gradual drift will eventually find themselves lost. Likewise, clinging too tightly to life's seeming constants can leave us unprepared when the ground shifts beneath our feet. Yet there's grace in this impermanence. Just as stellar motion creates new constellations over time, future civilizations will gaze at patterns we can't yet imagine. Our lives gain richness from their fluidity. The same forces that dissolve old certainties also carve space for reinvention. A collapsing star cluster seeds new star formation. A career-ending injury sparks an unexpected creative pursuit. A broken relationship leads to unforeseen growth. The universe doesn't erase, it rearranges. Our challenge isn't to mourn the illusion of permanence, but to embrace the artistry of change, to recognize that the very instability we fear is what makes existence vibrant, surprising, and alive. So the next time you find yourself longing for something to last forever, look up. Those fixed stars are racing through the void, writing stories in light that won't unfold fully for epochs. Their motion is a silent testament. Nothing is frozen, and that's precisely what makes the cosmos and our place in it so breathtaking. The universe has an unbreakable rule written into its very fabric: entropy. The slow but unstoppable march toward disorder governs everything from melting ice cubes to dying stars. Picture a child's meticulously built sandcastle at high tide. No matter how sturdy it seems, the ocean always wins. Star clusters are no exception. Their gravitational bonds, their intricate dances, even their dazzling beauty are temporary resistances against entropy's relentless pull. Over billions of years, the orderly structure of a globular cluster, thousands of stars orbiting a shared center, inevitably unravels. Stars escape, collisions redistribute energy, and the once tight community dissolves into the galactic background. This isn't a flaw in the system, it's the system itself. Entropy doesn't destroy, it transforms. Take the concept of violent relaxation, a process where stars in a cluster exchange energy through gravitational interactions, like billiard balls in a cosmic game. At first glance, this might seem to create order, stars settling into stable orbits, but in reality, it's entropy at work. Energy spreads unevenly, some stars gaining enough velocity to escape while others sink toward the core. The cluster's structure smooths out, homogenizes, and ultimately becomes less ordered. It's the celestial equivalent of a drop of ink dispersing in water. What began as a concentrated spot becomes a diffuse cloud. The universe prefers it this way. What's fascinating is how star clusters fight this inevitability and how futile that fight is. Dense cores in globular clusters, where stars packed together like sardines, temporarily resist entropy's pull. But even there, black holes lurk, their gravitational tugs redistributing energy in ways that accelerate the cluster's demise. It's a cosmic irony. The very objects that help hold clusters together also hasten their dissolution. This mirrors everyday experiences, like trying to maintain a tidy room. You might organize your desk, but dust settles, papers pile up, and chaos creeps back in. The difference is scale. Where we battle entropy for days or weeks, star clusters wage war for eons. Yet there's a deeper lesson in this universal tendency toward disorder. Entropy isn't just about things falling apart, it's about possibilities opening up. When a star cluster dissolves, its stars don't vanish. They become part of the galaxy's raw material, fuel for new star formation. The energy that once bound them now drifts through interstellar space, ready to ignite future stellar nurseries. In this way, entropy isn't an end. It's a recycling process, a cosmic reshuffling that keeps the universe dynamic and ever-changing. This duality, destruction and creation intertwined, echoes through all scales of existence. A fallen tree in a forest rots, but its decay nourishes new growth. A relationship ends, but the memories shape who we become. Star clusters remind us that entropy isn't something to fear. It's the universe's way of ensuring nothing stagnates, that every ending seeds a beginning. So the next time you feel overwhelmed by life's chaos, look up. Those glittering clusters slowly unraveling in the void are proof that disorder isn't the opposite of beauty. It's the very thing that makes beauty possible. Star clusters aren't just celestial curiosities, they're cosmic crystal balls, offering glimpses into the universe's ultimate fate. If these glittering assemblies, bound by gravity for billions of years, can't escape dissolution, what hope does the cosmos at large have? The answer lies in thermodynamics' oldest prophecy, heat death. Picture a cup of steaming coffee left on a counter. No matter how hot it starts, it will eventually cool to room temperature, its energy diffusing irreversibly into the surroundings. The universe is that coffee, and star clusters are the fading wisps of steam, early warning signs of a chilling inevitability. Heat death isn't explosive or dramatic, it's the quietest apocalypse imaginable. As the universe expands, galaxies will stretch apart until their stars are isolated islands in an ever-darkening void. Star formation will sputter out as gas clouds thin beyond recovery. Existing stars will exhaust their fuel, some collapsing into black holes, others fading into white dwarfs that cool over trillions of years into black, lifeless cinders. Even those black holes won't last forever. Thanks to Hawking radiation, they'll evaporate, leaving behind only a faint haze of particles drifting through an unimaginably vast and empty cosmos. The final state, a uniform, featureless expanse where no energy can be extracted, no work can be done, a thermodynamic graveyard where time itself becomes meaningless. But here's where star clusters offer a haunting preview. Their collapse isn't just about gravity's failure, it's about energy's slow leakage. The same two-body relaxation that ejects stars from clusters mirrors the universe's own energy redistribution. Stars stolen by tidal forces are like photons redshifted into oblivion by cosmic expansion. Both are victims of a system inexorably leveling out. Globular clusters, those ancient relics, show us how structure succumbs to chaos over time. Their dense cores are temporary bulwarks against entropy, just as galaxies today are temporary oases in an increasingly desolate universe. Yet there's a twist. Some theories suggest the universe's fate might be more complex than a simple heat death. Quantum fluctuations in a vacuum could theoretically spawn new big bangs, birthing pocket universes in a process called eternal inflation. Black holes might be gateways to other realities through singularities we don't yet understand. These ideas are speculative, but they hint that even in the face of entropy, the cosmos might have tricks we can't foresee. Star clusters don't get this reprieve. Their demise is absolute, their stars scattered beyond recovery. In that sense, they're purer prophets, unclouded by quantum uncertainties or multiverse fantasies. This cosmic fatalism isn't meant to depress. Instead, it reframes our place in the universe's story. We exist in a brief golden age, a sliver of time when stars still shine, galaxies still spin, and energy flows richly enough to power life. The same impermanence that dooms star clusters makes our moment precious. Their collapse teaches us that finitude isn't failure, it's what gives existence its poignancy and purpose. The universe may be marching toward silence, but for now it's singing, and in that song, however temporary, lies all the beauty we'll ever need. If the universe itself is fleeting, if even star clusters destined to outlive civilizations by billions of years eventually dissolve, what does that mean for how we treat our fragile, temporary home? It's a question that bridges astronomy and ethics, physics and philosophy. Some might argue impermanence justifies indifference. Why protect a planet, a species, or a culture that's doomed to vanish anyway? But star clusters offer a different lesson. Their transience isn't passive surrender, it's active participation in a grand cycle of transformation. When a globular cluster collapses, its stars don't just wink out, they become part of new galactic stories, their atoms recycled into future generations of planets and life. This cosmic repurposing suggests a radical ethic. Impermanence isn't an excuse for apathy, but a mandate for mindful stewardship. Consider the Hubble Space Telescope's iconic pillars of creation, image towering columns of gas where stars are born. Those pillars are also being eroded by stellar winds, their structures transient on cosmic timescales. Yet their destruction isn't wasted. It's the very process that disperses heavier elements necessary for rocky planets and life. Similarly, our brief window of existence on Earth carries responsibility precisely because it's temporary. Protecting biodiversity, curbing climate change, preserving cultural heritage. These aren't futile battles against inevitability. They're acts of reverence for the fleeting chances we're given. The stars teach us that value isn't diminished by brevity, it's amplified by it. This perspective reshapes how we might approach interstellar exploration. If humanity someday colonizes other worlds, Will we repeat Earth's patterns of exploitation, treating celestial bodies as disposable resources? Or will we recognize that even asteroids and exoplanets are part of a universe where every component, no matter how small or seemingly barren, plays a role in a dynamic, interconnected system? The ethical framework emerging from astrophysics isn't about conquering the cosmos, but collaborating with it. Like a star cluster's gradual dispersal, our expansion could be guided by principles of reciprocity, taking only what's needed, leaving systems intact for future cosmic evolution. Yet there's tension here. Astronomers recently discovered dark matter hurricanes, vast streams of invisible particles sweeping through our galaxy. These unseen forces remind us that despite our moral aspirations, the universe operates on scales and timelines that dwarf human concerns. Does stewardship matter in a cosmos where random events, asteroid impacts, gamma-ray bursts, can erase eons of progress in an instant? The answer lies in the paradox of the Pleiades. This young cluster's stars are destined to scatter, yet their current brilliance inspires art, science, and wonder across cultures. Our actions needn't be eternal to be meaningful. A civilization that nurtures its world, however briefly, creates ripples that outlast it, just as dying stars seed the galaxy with potential for new beginnings. Perhaps that's the ultimate takeaway from collapsing star clusters. They don't just model entropy, they model legacy. Their dissolution isn't an end, but a transfer of matter, energy, and possibility. Our responsibility in a transient universe isn't to build monuments that last forever, but to contribute something: knowledge, beauty, compassion, to the ongoing cosmic story. Whether our traces endure as radio signals drifting between stars or as fossilized layers in Earth's crust, what matters is that we honored our moment in the light. After all, the universe doesn't measure value by longevity. It measures it by transformation, and in that, even the briefest flicker can illuminate the dark. Star clusters don't fade quietly into the cosmic night. They go out teaching. Every gravitational tug, every stellar ejection, every black hole lurking in their cores is a data point, a clue to the universe's grand operating manual. Think of them as celestial cadavers, not in a morbid sense, but as invaluable subjects of dissection. By observing how clusters unravel, astrophysicists reverse engineer the laws governing galaxies themselves. Take the way stars escape from clusters, for instance. These runaway stars, flung out by gravitational slingshots, carry fingerprints of their birthplace's conditions. Their velocities and trajectories reveal the cluster's original mass, its age, even the invisible hand of dark matter that may have accelerated its demise. It's like finding a message in a bottle washed ashore. The words are faded, but the story they tell is priceless. This forensic astronomy extends beyond individual clusters. Computer models of collapsing clusters have reshaped our understanding of galaxy formation. When simulations accurately predict how a cluster like Palomar 5 stretches into a stellar stream, they validate not just stellar dynamics but the broader framework of cosmic evolution. These virtual experiments are cosmic time machines, letting astronomers rewind and fast-forward the lives of thousands of stars at once. The same code that predicts a globular cluster's core collapse also explains why some galaxies have halos of ancient stars while others don't. It's a reminder that the universe operates on fractal principles, patterns repeating from the smallest scales to the largest. But perhaps the most profound lesson lies in what clusters leave behind. The Omega Centauri cluster, for example, is suspected to be the remnant core of a dwarf galaxy devoured by the Milky Way long ago. Its survival, even in stripped-down form, offers a window into galactic cannibalism, how big galaxies grow by consuming smaller ones. Meanwhile, the ghostly streams of dissolved clusters like GD1 map the Milky Way's gravitational field with eerie precision, exposing hidden clumps of dark matter. These stellar fossils are more than debris, they're the universe's way of keeping records. A dying cluster's final act isn't just dispersal, it's disclosure, broadcasting secrets about everything from dark matter's distribution to the Milky Way's violent youth. What's striking is how these insights ripple beyond pure astrophysics. The algorithms developed to simulate cluster collapses now aid in predicting crowd behavior or tracking disease spread. The mathematics of stellar orbits informs everything from satellite navigation to quantum mechanics. Even the philosophical implications resonate. If something as vast as a star cluster can vanish yet still illuminate, what does that say about our own ephemeral contributions? Science, like the cosmos, thrives on legacy. Every ending, whether a supernova or a closed research lab, seeds someone else's beginning. So when you hear about a dead star cluster, don't picture a graveyard. Picture a classroom. The stars may be gone, but their light, literal and metaphorical, still reaches us, teaching, guiding, reminding. In their dissolution, they prove that knowledge, unlike matter, doesn't decay. It transfers, and in that transfer, the universe keeps its most enduring promise: nothing truly ends. It just becomes part of a larger story. The James Webb Space Telescope is more than a technological marvel. It's a time machine with a mission to decode the life and death of star clusters in unprecedented detail. Orbiting 1,000,000 miles from Earth, its infrared eyes pierce through cosmic dust that once obscured our view, revealing stellar nurseries and dying clusters alike with crystal clarity. Already, Webb has spotted globular clusters so ancient they predate the Milky Way itself, their faint light stretched and redshifted over billions of years. These aging stellar cities show signs of core collapse, their central regions densely packed with stars on the brink of gravitational chaos. But what's revolutionary isn't just the sharpness of these images, it's the stories hidden in their light spectra. Webb's instruments dissect starlight like forensic scientists, detecting chemical fingerprints that betray each cluster's violent history. Traces of heavy elements hint at long-ago supernova, while unusual stellar motions suggest invisible black holes prowling the cores. Yet Webb is just the beginning. The upcoming Nancy Grace Roman Space Telescope, set to launch in the late 2020s, will map millions of stars across hundreds of globular clusters in a single sweep. Imagine a cosmic census, tracking each star's position and velocity with precision, revealing how gravitational tides warp clusters in real time. Roman's wide-field observations will catch clusters in the act of dissolving, their outer stars streaking away into tendrils that future astronomers might classify as newborn stellar streams. Meanwhile, ground-based giants like the extremely large telescope in Chile will zoom in with unprecedented resolution, watching individual stars in distant clusters orbit each other, a front-row seat to the gravitational tango that drives their eventual collapse. These telescopes don't just observe change, they redefine our understanding of it. Recent simulations suggest some clusters might harbor multiple generations of stars, a finding that would upend traditional views of how these systems evolve. Webb's ability to spot faint, cooler stars could confirm whether younger stars really do form from the ashes of older ones within the same cluster, like phoenixes rising in slow motion. And then there's dark matter's role. By measuring how fast stars move in clusters' outer regions where visible matter can't account for their velocities, astronomers are closing in on dark matter's elusive influence. Each data point peels back another layer of cosmic impermanence, proving that even the laws of astrophysics are more like guidelines, rewritten with every new observation. What makes this era extraordinary isn't just the technology, but the philosophical shift it brings. Every time we improve our tools, we don't just see deeper into space, we see deeper into time, watching star clusters age before our eyes like time-lapse footage. The same cluster that appeared static in Hubble's images might reveal subtle tremors in Webb's gaze, its stars jostling like marbles in a slowly tilting box. These aren't just scientific breakthroughs, they're mirrors held up to our own transience. The light reaching Webb today from a dying cluster set out when Earth's continents were still forming. By the time that cluster fully dissolves, our species might be gone, our telescopes dust. Yet in this fleeting overlap of their demise and our curiosity, we touch something timeless, the urge to bear witness, to say, "We saw you." We tried to understand, so when Roman launches or the LT opens its massive eye, remember, they're not just instruments, they're bridges between human impermanence and cosmic eternity, letting us trace the arcs of stars that will outlive us by eons. And in their lenses, we find an unlikely comfort. The universe's chaos has patterns, its endings have beauty, and our brief flicker of awareness is just enough to catch a glimpse. The universe teems with star clusters, billions of stars bound together in glittering cities of light. Yet amid this cosmic abundance, one question echoes louder than all others: where is everyone? This is the heart of the Fermi Paradox, the unsettling contradiction between the high probability of extraterrestrial civilizations and their complete absence of evidence. If life is common, why does the cosmos feel so silent? Star clusters might hold a clue, not in their brilliance, but in their impermanence. Imagine a civilization rising on a planet orbiting one of those distant suns. By the time its signals cross the void, its home cluster could already be unraveling, its stars scattered by tidal forces or its core collapsed into a black hole. The window for cosmic conversation might be impossibly narrow, like two fireflies trying to find each other in a hurricane. Consider the timing. Globular clusters, those ancient relics from the early universe, formed when the Milky Way was young. Their stars are metal poor, lacking the heavier elements essential for rocky planets and complex chemistry. By the time enough supernova had seeded the cosmos with carbon, oxygen, and iron, many clusters were already entering their twilight years, their stars drifting apart or falling victim to galactic tides. The sweet spot for life, a stable star in a stable cluster with the right ingredients, might be vanishingly rare. Even if civilizations arose, their longevity could be measured against their cluster's disintegration. Like a sandcastle built too close to the surf, no matter how grand, the tide always wins. Then there's the isolation factor. Clusters are dense, with stars packed so tightly that planetary orbits could be disrupted by passing neighbors. A civilization might flourish, only to have its solar system hurled into the void by a gravitational slingshot, its radio signals fading into the background hum of the galaxy. Alternatively, the same density that threatens stability could also foster interstellar travel, but at a cost. Advanced societies spreading across a cluster would face the same existential deadline as their home stars: eventual dispersal. Their greatest achievements, their art, their knowledge, might vanish with them, leaving no trace but faint stellar streams. This perspective flips the Fermi Paradox on its head. Instead of asking why we haven't found aliens, we might consider whether anyone anywhere lasts long enough to be found. The same forces that make star clusters dazzlingly bright also ensure their eventual fade to black. Civilizations, no matter how advanced, could be like wildflowers blooming in a desert, breathtakingly beautiful, but gone before the next traveler passes by. The silence isn't a sign of absence, it's a testament to the universe's relentless impermanence. Yet there's a glimmer of hope in this cosmic solitude. If civilizations are fleeting, then every moment of connection becomes infinitely precious. The fact that we're here at all, in this sliver of time when the Milky Way's clusters still shine and our technology lets us search the skies, is a kind of miracle. The stars don't need to answer for the universe to feel alive. Their silence isn't empty, it's full of possibilities, each one a reminder that existence, however brief, is its own kind of answer. Imagine a planet orbiting a star in the heart of a globular cluster, a world bathed in perpetual twilight, with dozens of neighboring suns gleaming like streetlights in some celestial metropolis. For billions of years, this civilization, if it exists, would have known only stability, its skies ablaze with the light of tightly packed stars. But as the cluster ages, gravitational chaos ensues. Stars vanish, ejected into the void. Others spiral toward the core, their orbits destabilized by black holes or close encounters. The once crowded heavens thin out, leaving this hypothetical civilization staring into an ever-darkening abyss. Could life persist as its cosmic neighborhood unravels? Astrobiology suggests the answer hinges on two brutal truths: adaptability and luck. The first challenge is the shrinking habitable zone, the orbital region where liquid water can exist. In a stable cluster, a planet might enjoy gentle warmth from multiple stars, like a campfire surrounded by friends. But as those stars disperse or die, temperatures plummet. A world once perfectly positioned could freeze over in geological instants. Yet extremophiles on Earth, organisms thriving in boiling vents or Antarctic ice, prove life clings tenaciously even in shifting environments. Microbial colonies might retreat underground, tapping geothermal heat as stellar light fades. Intelligent species, if they arise, could engineer solutions: orbital mirrors, artificial suns, or migrations to surviving stars. But these are stopgaps. The real test comes when the last neighboring star drifts away, leaving a solitary sun to shoulder the burden of warmth. Then there's the threat of radiation. Young clusters simmer with massive stars that die violently as supernova. A single nearby explosion could sterilize planets light years away. As clusters age, the risk shifts. Collisions between white dwarfs or neutron stars unleash gamma-ray bursts, cosmic death rays capable of stripping atmospheres across entire solar systems. Life would need to evolve, shielding perhaps deep ocean habitats or planetary magnetic fields stronger than Earth's, to survive these random apocalypses. The odds aren't zero. Earth's own history includes mass extinctions from space-borne catastrophes, yet life always resurged. But in a dissolving cluster, such events would be frequent, relentless, and inescapable. Perhaps the cruelest hurdle is time itself. Complex life took nearly 4 billion years to emerge on Earth. Globular clusters, though ancient, might not offer stable enough conditions for such slow development. Their turbulent cores, where stars jostle like commuters in a crowded train, could disrupt planetary orbits long before intelligence arises. Open clusters, gentler but shorter-lived, might disperse before life advances beyond microbes. This cosmic deadline echoes humanity's own race against time, our brief window to grasp the universe before our star, or our civilization, meets its end. Yet nature thrives on paradox. Some models suggest cluster collapse could spark life. As stars crowd toward the core, their gravitational interactions might fling icy comets outward, seeding planets with water and organic molecules. Supernova shocks could compress nearby gas clouds, triggering new star formation even as the old cluster dies. In this light, collapse isn't just an end. It's a catalyst, scattering the ingredients for life across the galaxy like dandelion seeds in the wind. The deeper lesson lies in resilience. From Earth's hydrothermal vents to the hypothetical oceans of Europa, life demonstrates a stubborn refusal to surrender. A cluster's demise might be inevitable, but its legacy could live on in rogue planets carrying frozen ecosystems between the stars, or in the radio whispers of a civilization that refused to go quietly. After all, impermanence doesn't erase meaning, it demands it. The stars may scatter, but the atoms they forge, the carbon in our cells, the iron in our blood will endure, recycled into whatever comes next. In that sense, life doesn't just survive collapse, it becomes part of the universe's endless reinvention. Colonizing star clusters sounds like the ultimate sci-fi fantasy, a sprawling metropolis of civilizations thriving among thousands of neighboring suns, their skies ablaze with perpetual daylight from tightly packed stars. But the dream crashes against a brutal reality. Star clusters are cosmic death traps, their very beauty a lure into gravitational chaos. Picture building a city on a sinking island, where the ground beneath you is constantly shifting, neighbors vanish without warning, and the tides could swallow everything at any moment. That's life in a star cluster, the same density that makes them dazzling stars crammed light years closer than in our sparse galactic neighborhood also makes them unstable. A passing star could yank your planet into a new orbit, hurling it into deep freeze or frying it alive. A black hole lurking in the core might slingshot your solar system into the void like a pebble from a catapult. Even without these disasters, clusters are dissolving, their stars drifting apart on timescales that dwarf human civilization but feel like a blink to the universe. Yet the temptation is undeniable. Imagine the resources. A single globular cluster like Omega Centauri holds millions of stars, each potentially ringed by planets, asteroids, and untapped energy. For a species hungry for expansion, it's like stumbling upon a gold rush in space, except the gold is also radioactive, booby-trapped, and slowly evaporating. The irony is crushing. The places with the most raw materials are also the least hospitable to long-term survival. It's the cosmic equivalent of finding an oasis in a desert, only to realize the water is poisoned. This tension between ambition and reality is etched into humanity's DNA. We're drawn to the impossible, whether it's climbing Everest or planting flags on Mars. Star clusters represent the pinnacle of that longing, not just settling a world, but conquering an entire stellar neighborhood. Early explorers might shrug off the risks, betting on technology to tame the chaos. They could build swarm habitats anchored between stars, or harness black holes as power sources. But technology can't rewrite physics. No shield will stop a rogue neutron star from pulsing your colony into oblivion. No engine will outrun the Milky Way's tidal forces peeling your cluster apart. The universe doesn't negotiate, but here's the twist: futility doesn't equal meaninglessness. The very act of reaching for a star cluster, knowing it might reject us, reveals something profound about human nature. We're the only species, as far as we know, that gazes at the heavens and sees not just points of light, but possibilities. Star clusters might be terrible places to live, but they're perfect metaphors. They remind us that growth isn't about permanence, it's about adaptability. The civilizations that survive won't be the ones stubbornly clinging to unstable ground, but those nimble enough to ride the chaos, harvesting resources while they can, then moving on when the tides turn. So perhaps the dream isn't futile after all. It's just misunderstood. Colonizing a star cluster isn't about building forever. It's about shining brilliantly, however briefly, in a universe that guarantees nothing but change. The stars don't owe us a home, but they do offer a stage, and for a species like ours, that might be enough. There's a quiet moment that comes when you stare into the night sky long enough, when the vastness of those glittering stars stops feeling like a spectacle and starts feeling like a mirror. It's not just their light that reaches us across the eons, it's their lesson. Every star, every cluster, every galaxy we see is already changed or gone by the time its light touches our eyes. We're literally watching the past unravel in real time, a cosmic magic trick where the illusion isn't the movement but the stillness, and in that realization there's an unexpected comfort. If the universe itself is a fleeting arrangement of temporary structures, why do we hold ourselves to impossible standards of permanence? Think of a dying star's final act, a supernova. In its last moments, it doesn't cling, it releases, it scatters the elements forged in its core across space, seeding future worlds with the building blocks of oceans, mountains, even life itself. That's the paradox of impermanence, destruction as creation. We're made of star stuff, as Sagan famously said, but more poetically, we're made of goodbye. Every atom in our bodies was once part of something that no longer exists, and yet here we are, not despite that impermanence, but because of it. The stars teach us that endings aren't cancellations, they're transformations. This isn't just astronomy, it's a survival strategy. Modern life bombards us with the myth of forever eternal youth, unshakable stability, relationships that never fray. But the cosmos whispers a different truth. The Japanese practice of kintsugi, repairing broken pottery with gold, celebrates flaws as part of an object's history. The cracks aren't hidden, they're illuminated. Star clusters do the same. Their collapse isn't a failure of design, it's the design itself. The Pleiades won't always be the seven sisters. Orion's belt will loosen. But their beauty isn't diminished by their temporariness. If anything, it's deepened. So how do we translate this cosmic perspective into daily life? Start small. Watch a sunset without reaching for your phone. That golden light is already vanishing even as you see it. A real-time lesson in letting go. Or consider the cherry blossoms celebrated in Hanami, where entire cultures pause to honor flowers that will wither in days. These aren't morbid rituals, they're celebrations of presence. The blossoms don't mourn their fate, and neither do the stars. They simply burn or bloom as brilliantly as they can with the time they're given. Here's the secret the cosmos knows but we often forget. Peace isn't found in resisting change, but in riding its current. A star cluster dissolving into stellar streams isn't a tragedy, it's a liberation. Those stars aren't lost, they're set free, and so are we, every time we release our death grip on how things should be and embrace what is. The universe has been practicing impermanence for 13 billion years. We're just learning to dance to its rhythm. So the next time you feel the ache of time passing, a child growing up, a dream shifting shape, look up. The stars are nodding back, their light a silent reminder. This too is part of the dance. Standing under a sky ablaze with stars, it's easy to feel small, but not in the way you might expect. This isn't the crushing smallness of insignificance. It's the liberating kind, the realization that your worries, your deadlines, your endless to-do lists are just fleeting whispers in a universe that's been unfolding for 13 billion years. That's the magic of mindfulness under the stars. Each pinprick of light you see isn't just a distant sun, it's a timestamp, a cosmic postcard from a moment that no longer exists. The light from Vega, 25 light-years away, left the star when you were learning to ride a bike. The glow of the Pleiades began its journey when humans were building the first cities. Gazing upward isn't just observation, it's time travel, a visceral reminder that the present moment is all we truly have. The practice is simple. Let your breath sync with the rhythm of the night. Inhale as a meteor streaks across the sky. Exhale as it vanishes. Notice how the stars don't rush. They pulse, flicker, and fade at their own unhurried pace, indifferent to human clocks. There's a reason ancient cultures built Stonehenge and the pyramids. They weren't just tracking the heavens, they were aligning with a tempo far grander than human impatience. Modern life thrives on urgency, but the cosmos operates on a scale where even the slow death of a star is over too soon. When you match your heartbeat to that rhythm, something shifts. The anxiety of not enough time dissolves into the quiet certainty that there's exactly enough, because time itself is an illusion, a human construct the universe never signed up for. This isn't passive stargazing, it's active participation. The Andromeda galaxy, barreling toward us at 300,000 kilometers per hour, will collide with the Milky Way in 4 billion years. Yet tonight, it's a smudge of light you can cover with your thumb. Hold that contradiction in your mind, the unimaginable force barreling toward us, and the delicate stillness of this moment. That's the heart of cosmic mindfulness, holding vastness and intimacy in the same thought without needing to resolve the tension. The stars don't explain themselves. They simply are, and so are you. The darkness helps too. Light pollution steals more than our view of the stars. It erases the soft edges of our thoughts. In true darkness, the mind expands to fill the space between stars. You start to notice how your breath fogs in the cold air, how the scent of damp earth rises around you, how the silence isn't empty but humming with crickets and distant wind. These sensations anchor you to the present, weaving your awareness into the fabric of the night. Astronomers call this dark adaptation, the gradual sharpening of vision as your eyes adjust. But it's also a metaphor. The longer you sit with impermanence, the clearer it becomes. Life isn't about clinging to light, but learning to see in the dark. And then there's the ultimate lesson. The stars themselves are meditators. They don't resist their fate. A red giant doesn't rage against its collapse into a white dwarf. A supernova doesn't apologize for its brilliance. They follow their nature without hesitation, burning brightly until they can't. When we align with that truth, something unexpected happens. The fear of missing out becomes the joy of showing up. The pressure to leave a legacy softens into the satisfaction of being part of something vast and fleeting. You don't need to etch your name in the cosmos to matter. You just need to witness it fully, deeply while you're here, so the next time you step outside and look up, don't just see the stars, let them see you. Not as a bystander, but as a participant in this grand, temporary dance. The light reaching your eyes tonight has traveled farther than you ever will, only to meet you in this exact moment. And when it's gone, when the stars fade at dawn or burn out in distant millennia, what remains isn't their light, but the imprint they left on your attention. That's the gift of mindfulness under the stars. It doesn't ask you to outlast time, just to savor it. The vast, swirling arms of the Milky Way may seem infinitely distant from Earth's fragile biosphere, but the forces unraveling star clusters and the systems destabilizing our planet share an eerie kinship. Gravity may be the architect of celestial dissolution, yet humanity has become its terrestrial equivalent, an invisible hand tugging at the threads holding Earth's ecosystems together. Like stars ejected from a cluster by gravitational chaos, species vanish from destabilized habitats, their absence rippling through food webs. Ice sheets retreat like galactic tidal forces stripping a cluster's outskirts, while ocean currents, those planetary circulatory systems, stutter under the weight of meltwater, mirroring how dark matter perturbations disrupt stellar orbits. The mechanisms differ, but the pattern repeats. Systems that thrived in equilibrium for millennia now teeter toward irreversible transformation. Consider the parallels in timescale. A globular cluster's collapse unfolds over billions of years, its stars drifting away so gradually that no single generation of observers would notice. Earth's climate operates on a similar principle of incremental change until it doesn't. Just as a star cluster's disintegration accelerates once its core density passes a critical threshold, climate systems harbor tipping points, methane released from thawing permafrost, rainforests drying into savannas, ice sheets shattering into albedo-altering fragments. These aren't hypotheticals. Greenland's ice loss has quadrupled in 2 decades, echoing how astronomers watch cluster cores contract with gathering speed as gravitational bonds weaken. The universe operates on a continuum of slow decay punctuated by sudden unraveling, and Earth is no exception. Yet there's a crucial divergence. Star clusters collapse under immutable physical laws, but planetary systems falter under avoidable pressures. The carbon dioxide thickening our atmosphere isn't an act of cosmic inevitability. It's the residue of choices. Here, the stellar metaphor becomes a warning with startling clarity. Palomar 5 stars didn't choose to be torn apart by the Milky Way's tides, but humanity chooses daily whether to intensify Earth's vulnerability. The 2023 breach of the 1.5 degrees Celsius threshold wasn't destiny. It was the culmination of decades where short-term growth trumped long-term equilibrium, much like how a cluster's eventual fate is sealed by countless small gravitational nudges. The universe offers no second chances to collapsing clusters, but it does provide something equally profound: precedent. Just as astronomers reconstruct a cluster's history from stellar streams and chemical fingerprints, paleoclimatologists trace Earth's past climates through ice cores and sediment layers. Both records whisper the same truth: systems tolerate stress until they don't. The Petam Paleocene-Eocene thermal maximum 56 million years ago saw temperatures spike 8 degrees Celsius, triggering mass migrations and extinctions. Yet that event released carbon 10 times slower than modern emissions. The cosmos teaches that recovery isn't about reversing collapse, but adapting to its aftermath. Forests regrow after wildfires, just as new stars ignite from the debris of dead clusters. But the survivors are never the same. Perhaps the most poignant lesson lies in perspective. From space, Earth is a fragile blue pendant hung in the void, a celestial object as temporary as any star cluster. The difference is awareness. A dying cluster doesn't witness its own dissolution, but humanity watches real time as glaciers calve, corals bleach, and wildfires rewrite landscapes. This consciousness carries moral weight. When the stars scatter, they leave no regrets. When ecosystems fail, their loss echoes through human generations. The constellations won't mourn the Pleiades when its stars disperse, but a child born today will inherit the world we're currently unmaking. That's where the stellar metaphor transcends astronomy. Cluster collapse is inevitable. Earth's degradation isn't. The same cosmic forces that dissolve star clusters also birth new ones from their remnants. Our challenge and opportunity is to emulate that cycle of renewal rather than the chaos of collapse. Reduce emissions and carbon cycles rebalance, restore wetlands and water systems regain resilience. The universe's impermanence isn't a mandate for resignation, but a call to stewardship. After all, stars don't choose their fate. We still can. When a star cluster collapses, it doesn't just vanish. It scatters the seeds of its own rebirth across the cosmos. Picture the final moments of a massive globular cluster, its outer stars ripped away by galactic tides, its core contracting under the weight of its own gravity. As those dying stars exhale their last breaths, they release vast clouds of gas, hydrogen, helium, and heavier elements forged in their nuclear furnaces. This expelled material doesn't simply dissipate into emptiness. Instead, it drifts through interstellar space until gravity, that relentless sculptor, takes hold once more. Dense pockets within the gas begin to collapse, heating up until nuclear fusion ignites, and new stars burst into existence. The death of one stellar family becomes the birth of another, a celestial phoenix rising from the ashes. Take the Orion Nebula, a stellar nursery visible to the naked eye. Its swirling gases and young, hot stars didn't emerge from nothing. They're the legacy of older stars that lived, died, and recycled their remains into this dazzling cradle of creation. The Trapezium cluster at its heart, with its brilliant blue stars, is a direct descendant of prior stellar generations. This cycle isn't unique to Orion. Across the galaxy, from the Carina Nebula's towering pillars to the faint glow of the Eagle Nebula's pillars of creation, star-forming regions are built on the remnants of their predecessors. Even our own solar system likely owes its existence to a long-vanished cluster whose supernova enriched the gas cloud that birthed the sun. The physics behind this rebirth is as elegant as it is profound. When massive stars die in supernova, they don't just release gas, they shockwave it, compressing nearby clouds and triggering chain reactions of star formation. Smaller stars like red giants contribute too, shedding their outer layers in gentle stellar winds that replenish the interstellar medium. These processes aren't random, they follow patterns as precise as seasons on Earth. Just as winter's decay nourishes spring's growth, stellar death clears space for new beginnings. The universe operates on a principle of conservation, not just of matter and energy, but of possibility. What's striking is how this cycle mirrors the rhythms of life on Earth. Forests thrive on the decay of fallen trees, their nutrients fueling saplings. Coral reefs rebuild from the skeletons of past generations. Human cultures rise from the ruins of earlier civilizations, carrying forward fragments of knowledge and art. The cosmos reminds us that destruction and creation aren't opposites, they are partners in an endless dance. When we look at a star cluster's collapse, we're not witnessing an end. We're seeing a transformation, a reminder that even in the coldest depths of space, nothing is ever truly lost. This cosmic recycling also reshapes our understanding of time. A star's lifespan might span billions of years, but its influence stretches far beyond its death. The iron in our blood, the calcium in our bones, these elements were forged in stellar cores and scattered by supernova long before Earth existed. We're not just observers of this cycle, we're participants made from the remnants of stars that ceased to shine eons ago. The universe doesn't have a landfill. Every ending is a redistribution, every collapse a prelude to something new. So the next time you hear about a dying star cluster, don't think of it as a tragedy. Think of it as a cosmic relay race where the baton of stardust is passed from one generation to the next. The stars we see tonight are temporary, yes, but their legacy is eternal, woven into the fabric of whatever comes next. In a universe where even endings are beginnings, the only true constant is renewal. Star clusters don't whisper their lessons, they blaze them across the cosmos in silent supernova and drifting stellar streams. Their impermanence isn't a flaw in the universe's design, it's the very heartbeat of existence. Every collapsing core, every star flung into the void, is a testament to a truth we often resist. Endings aren't interruptions. They're part of the music. Imagine if the Pleiades clung to its stars with gravitational desperation, refusing to let them disperse. The night sky would lose its poetry, frozen in an unchanging tableau. Instead, the cluster's slow unraveling gifts us with shooting stars, rogue planets, and the raw materials for future solar systems. Its surrender to time becomes a creative act. This cosmic perspective flips our instinctive dread of impermanence on its head. We mourn fading relationships, aging bodies, and eras of life that slip through our fingers like stardust. But the stars ask, would you truly want a universe where nothing ever changed? No autumn leaves, no children growing, no art evolving. The ache of loss and the thrill of new beginnings are two sides of the same supernova. When a globular cluster like Omega Centauri finally dissolves, its stars don't vanish, they become part of the Milky Way's grand spiral, their atoms weaving into stories yet untold. Our lives, however brief, are no different. There's a quiet rebellion in embracing this truth. Modern life sells us the myth of control, anti-aging creams, rigid 5-year plans, the illusion that we can freeze happiness like a snapshot. But the stars laugh at our hubris. They've watched empires rise and fall, continents shift, and galaxies collide. Their message isn't nihilism, it's liberation. When you stop fighting impermanence, you start seeing its gifts, the way twilight makes daylight sweeter, how love burns brighter knowing it's fleeting. The Japanese concept of mono no aware, the poignant beauty of transient things, captures this perfectly. A cherry blossom's fragility isn't a defect, it's the source of its power. So tonight, step outside, look up, those glittering points of light, they're already gone, their light just now reaching your eyes across the chasm of space and time. And in that realization, there's an unexpected comfort. You don't need to outlast the stars to matter. You just need to shine while you can, to love fiercely, create boldly, and leave trails of kindness like stellar winds shaping nebulae. The universe isn't judging your lifespan, it's waiting to see what you do with your stardust. Hit subscribe to keep exploring these cosmic connections with us. Drop a comment below. What's one fleeting moment you'd relive if you could? The stars may not answer, but the act of asking aligns you with the oldest rhythm of all, the dance of light and time, forever changing, forever new.